Hello, everybody. My name is Noah Newman. I'm technology editor with Farm Equipment, and welcome to today's Farm Equipment webinar. Ag Autonomy is coming. Is your dealership ready? Well, we're about to find out. The Hexagon Autonomy and Positioning team is here to discuss the outlook for autonomy, different types of autonomous machines, and also talk about what dealers need to prepare for the autonomous future. So our presenters today are James Szabo, Ag Autonomy Portfolio Manager for Hexagon, and Chad Hudipole, Portfolio Marketing Manager for Hexagon. Let's go ahead and jump right in. So Chad and James, I'll throw it over to you, and you guys can get started with your presentation. Take it away.
All right. Thank you, Noah. Thank you to everybody for joining today. We're here to discuss the topics and ask the questions about ag dealerships and really to determine, are you prepared for autonomy in your dealership? But first, let's start by answering, who is Hexagon? Hexagon is the global leader in measurement technologies. We provide the confidence that vital industries rely on to build, navigate, and innovate. At Hexagon, we've been working with agriculture OEMs for decades. We provide robust positioning and reliable guidance, steering, components, software, all types of technology that integrate with the technology that farmers rely on through many different types of OEMs or aftermarket solutions. If you're not familiar with Hexagon, you may recognize Hexagon's ag-facing brands of Novatel and TerraStar, both longtime staples in advanced ag systems. Our technology provides the foundation for precision agriculture. As we move towards autonomous machines, it answers the key questions of where am I, what's around me, and how do I get to my destination? As mentioned, I'm Chad Hudipole, the Ag Portfolio Marketing Manager at Hexagon. I've been learning and evolving in precision ag for over 20 years, the last 10 here at Hexagon. I'm coming from rural Iowa, where I have a background with growers, dealers, and OEMs. And with me today is our subject matter expert, James Szabo.
Thanks, Chad. I'm James. I'm the Agriculture Autonomy Portfolio Manager here at Hexagon. I've been working specifically on autonomy and supporting OEMs in their innovations and developments for the past 8 years, and prior to this, developing precision farming technologies and markets. So for the last 18 years, helping dealers, farmers, and OEMs transition from machinery sellers and users to precision farming embracing businesses. Live in the North Lincolnshire, north of the UK, on a family farm here with mixed arable and some livestock as well. I grew up in agriculture. I live and breathe agriculture. And straight after this call, I'm collecting some bales that have been baled this afternoon. So it's very much part of everything that I do.
All right, thanks for joining, James. So in the audience today, we have a mixture of machinery dealers, service providers, manufacturers, as well as economic analysts. Before we go into the technical considerations that an ag dealership must be equipped with to adequately sell and support autonomous systems, we must first answer why we at Hexagon and the others in the industry are investing so much time and effort into autonomy. Really, farming continues to come under more and more pressure year in and year out. The growing global population, we've all heard this numerous times, but ultimately they want cheaper food, cheaper fuel, and cheaper fiber. But more good and profitable farmland's not being created. If anything, it's being consumed with urban sprawl, greedy corporate landlords, or even solar farms, or so the message boards say. Genetic trait advances are mostly already achieved, and environmental regulations continue to create additional challenges for many. Climate change is leaving us with drier acres and more larger storms, which impact that ideal farming window. So how do we feed the world and keep, or in some cases make, farming profitable? We have to improve our efficiencies. We have to get more out of everything, more out of the limited labor that is available, more out of the inputs we're investing into our fields, and we have to improve the soil that's producing. Autonomy will be the primary adoption that makes this possible. Autonomy will change our footprint, lessen the demands of labor, and enable the producer to produce more with less. Autonomy must be safe, robust, and reliable. And at Hexagon, that's what we do. When it has to be right, it has to be Hexagon. So I've made it sound pretty simple, and you're probably wanting me to tell me, how are we going to do all of this? But first, let's start with what is autonomy? Autonomy in agriculture. It's not a one and done thing. We're not going to snap our fingers and have some new product introduction at Farm Progress Show or whatever trade show that's going to automatically turn a full farm fully autonomous. Well, it might for some BTO, but certainly not the masses. Autonomy, especially in agriculture, is a transformative journey. Autonomy will impact the whole farm. It's more than just a single point line item on an invoice, but it will be an entire workflow. It will be achieved through a series of steps or levels to get you to the end goal. Today, our goal is to help you prepare the dealership for the journey into autonomy. As mentioned, agriculture is constantly changing. The way we do things with the technologies available to us, it comes in many ways, from a baler or a picker, or even a cotton picker that bales. Each of these advancements came in steps and ultimately changed the farms they enter. Autonomy will be the same. We have already achieved many milestones that put us closer than ever to full autonomy. Some could argue even 150 years ago, we had examples of level 2 and 3 autonomy already. Most horses knew their way back to the barn. By the standards set out, that's kind of a conditional autonomy. And to be a bit more serious, the industry have loosely defined these standard levels of automation that exist. The technology advancements in ag have already achieved commercially available solutions through level 3. The sales channel, service standards, and dealerships have also changed throughout these accomplishments. James, as you're the subject matter expert on ag autonomy within Hexagon, how do you advise this industry to prepare for the evolution toward autonomy?
Yep, thank you, Jeff. Well, I think the first thing to note is to look back at where we've come from and the skill sets that have evolved with where we've come from. So if we take a jump back to, let's use an example of 100 years ago. Harry Ferguson released the 3-point linkage on the Massey Ferguson tractor here in the UK. And the technology itself was very simple, but obviously state of the art at the time. But the sales team had to focus their efforts on building a relationship with the farmer and becoming their trusted supplier. And for this, they needed to know the mechanical knowledge and the fundamental of understanding of what they were selling. And from an aftermarket perspective, it was, again, the mechanical knowledge. This is the iron, this is the oil, this is the engine, this is transmission, and then maintenance of those parts, or maintenance and supply of those parts. And that was a core understanding. And that's still very true today in any level 0 system. We still have level 0 tractors, by far the largest market, where not everything is automated, or there are no automation functions on that machine. So if we take a step forward, we start to see the rise of precision agriculture. And this model of a level 0 automation stayed fairly consistent until these new technologies started to emerge, especially with the rise of precision agriculture. So now with more accessible technologies like GPS, we can add spatial variants to what we're doing, and no longer was the field stuck to one operation or one task or one performing metric across the whole field, but we can geospatially split it up into subdivisions, and that's allowed precision soil applications of fertilizer. We can do real-time applications, but this has inevitably led to more complexities within the field. So if we have a look at the skills needed for some of these driver assistance technologies, well, the sales team is having to have a conversation about immediate tangible gains. So for auto steer, the immediate tangible gain was reduced operator fatigue, less overlap in the field, leading to direct savings on inputs like fuel, seed, fertilizer. The skill set is clearly articulating this immediate return on investment and showing them how the technology that still requires a driver's full attention can still significantly enhance and with great precision with a relatively low barrier to entry. So that's what the sales team really embraced with the adoption of level 1 automation, really the precision farming side. On the after sales side, the role was foundational. It means that you are experts in the initial setup and calibration of guidance systems. We've all been those that have been in the dealership world with precision farming knows that it takes a lot of effort, a lot of skill, and a lot of experience to properly set up and calibrate a guidance system to meet the expectations of the farmers, of the customers. But farmers need to see those lines being perfectly hit right from the start. Now, this has led to a new type of skill set. Technicians must be adept at basic electrical diagnostics, sensors, GPS receivers, and be comfortable walking farms through troubleshooting steps over the phone or in person. It's all about ensuring the farmer gets the system working reliably day in, day out, building confidence in their new technologies and their investment. And when we start to look at the next levels of automation, these focus around tools and functions of the machine, which make the operator's life easier and sometimes safer. So a real-time example, which is very prevalent, is auto steer. It's what we see, but it is a level of automation. And beyond just auto steer, if we start looking more and more at what the actual machine is doing, we've got cruise control in there, we've got draft control, and we've got automation tools to automate the implement. So we have a lot of these little parts of technology just doing these little things to make our life a lot easier. And they've all crept into our machines over the last 50 years. So from a dealer's perspective, they have already learned some new skills about machine control systems, about GNSS, for example, about how to tune and optimize a system to really benefit the farmer. Now, at the moment, or in a level 1 scenario, most of these technologies are very foundational, but now they need to get them to talk to each other. It's very rare that we have a farm with a single brand that is able to achieve all of their agricultural needs, whether that's planting, seeding, fertilizer, spraying, all the cultivations. It's very rare that we have a single fleet. So we need these things to start communicating with each other. So the next level of autonomy is not only a matter of understanding it, but actually looking at the bigger picture. So level 2 is partial automation, which takes all the foundational technologies in precision agriculture and machine control and allows them to work together. So for example, a steering system linked with a speed control system, linked with a farm management system, linked to your sprayer or your fertilizer applicator, whatever, the whole ecosystem working together. And these functionalities don't necessarily have to be integrated as part of the original platform purchase. These could be purchased or provided by separate manufacturers or different service providers, which is why the sales team toolbox needs to expand to where the sales team understand what works with what and start to understand and talk to the customers about how the different systems perform or whether those systems are actually important to that farmer. So they're moving into more of a consultative selling role. So it's no longer just looking at a single part number of the Massey Ferguson 3-point hitch, for example, but looking at everything that goes into that farming operation. All of these integrated systems need data management, and this has become a hot topic over the last 10 years. We have ISO XML, exceptionally popular in Europe. We have shape files, and then we have any number of proprietary formats. And all of those need to be consumed by farm management systems. And understanding how all of this plays together is really important because it's a big barrier as to how these technologies can be adopted by the end user. And it's only until they are adopted and embraced, do they really bring all the extra benefit? So these increasing complexities mean that the sales team also need to be able to, in most situations, train the consumer or the customer how to actually leverage and get the most out of these newer digitally based technologies. So the next step is we have all of these data, we have all of these machine control functions, we have them all working together, but the drive for greater efficiency constantly pushes innovation in industries that need it the most. And this is where we are in agriculture. Farmers are always expected to grow more with less land, with less labor resources, less fuel resources, and greater legislation. And this is all to feed a growing population. So it is this perfect storm of all of the variables heading in the wrong direction, making it harder and harder for farmers. So this is really pushing us to the next levels of automation that we're starting to see emerge into the market today, which is our level 3 conditional automation. When we start to reach level 3 automation, then a task can be completed with no human intervention at all, but in a limited number of use cases and scenarios. A human is still responsible for the actual operation, but the workflow from start to finish could be completed autonomously in ideal conditions. And I think everyone in the call is aware there's no such thing as an ideal condition in agriculture. The weather's never quite right, the soil conditions are never quite right. Perfect conditions for the operation today may be detrimental conditions for the same operation tomorrow. But what does level 3 automation mean for the dealer? Well, the salesmen still have all of the skills and knowledge and basic machine know-how, but when we start to operate a full task, we're no longer limiting ourselves to the domain of the machine. We need to understand the entire workflow of that task and everything that goes into it. So now the product being sold by the dealer is not necessarily a part number, but a part in an entire workflow. And it is essential to understand how that part fits within the bigger scope. So this means an understanding of the customer's workflow, not just the customer's task, but the customer's workflow, and understanding how your solution fits within that workflow, understanding communicating the value to which you bring to that workflow. So from an after sales perspective, if your component within this bigger picture fails, we need to be responsive in order to keep that workflow operational. And that's where we're going to see more and more remote diagnostics and support and more integration of other technology layers to try and speed up the readiness and response to support this workflow. But there are other areas which will need new skill sets. With remote connectivity becomes a new risk of cybersecurity. Understanding how your remote influences on that machine may also be remotely influenced by a bad actor. In level 3 autonomy, we'll start to see new sensors, new perception systems, whether they're cameras, LiDARs, radars, ultrasonics, whatever that sensor may be, then in all likelihood, that sensor will need replacing if it's damaged. And if it needs to be replaced, there's a certain level of diagnostics and repair. And of course, calibration once it has been replaced. And finally, depending on what parts of that automation workflow you're responsible for, then it may be that the sales team need to understand the limitations and the functionalities of these machines and help communicate the limitations and expectations of what that machine can do. We don't want to be overselling a level 3 autonomous product, which is conditional automation, as something that is going to solve every single problem on that farm. So looking at the next steps, we've automated the majority of the task. However, up until this point, there's always been a one-to-one relationship between the human and the machine, meaning you've not really solved any labor limitations. And that's where our next level of automation really starts to provide a return on investment for the customer. At level 4, we enter into the realm of high automation. So within defined conditions, the vehicle operates completely autonomously without requiring the operator to be ready to intervene. A human might still be on the farm supervising multiple machines, but they're not expected to take control during the autonomous operation. So for a sales individual, this is a truly transformative conversation. You are no longer just selling a machine. You are selling a new labor model and a shift in farm management. Imagine a single operator supervising a fleet of autonomous tractors from a command center, or a machine operating 24/7 without a driver. Your sales team need to be strategic consultants, helping farmers redesign their operations and help quantify the labor savings achieved, and then understand the implications of what these processes can have on their entire farm ecosystem. This involves selling comprehensive service level agreements, guaranteed uptimes, discussing ROI based on sustained, precise, and potentially all round the clock operations. A big change in the way that a sales team really engages with their customers compared to the technologies which are readily available today. After sales for level 4 really demands a highly specialized, proactive, and data-driven approach. Technicians need to have a deep expertise in robotics, have a fundamental understanding of artificial intelligence, because that's going to be a huge part of the way that these systems are able to cope with the variance in agriculture, and then understand complex sensors and sensor fusion systems, so different sensors working together. They must be adept at advanced remote diagnostics, capable of accessing and analyzing real-time data streams. Preventative failure and predictive failure will be a real success point for these level 4 automation systems. So a support network needs to be robust. It needs to have a robust infrastructure, meeting the cybersecurity aims and goals that are needed in order to keep the whole ecosystems operational. We're moving beyond just fixing problems to actively ensuring the continuous optimized performance of an entire autonomous fleet, often without any supervision. And if there is supervision, it's going to be remote or off-site. So level 4 is really today where we're starting to see little pieces getting solved. Some may claim a fully level 4 automated system, but unfortunately, there is no such thing where a ag robot is able to cope with every single use case so far. When we start to talk about solving everything, well, level 3 and level 4, that's in development today, and we're just starting to enter the market. And it's really the dawn of automation, and this is where the most development focus is taking place. Now, there is always going to be more demand for the next level. They're wanting the next stages, they're wanting the next big thing. Well, a bit of an understanding of what that means for level 5 automation is this is the ultimate vision. And it's going to be a long time before we get there, but it's always important to have a look at the horizon. So this is where a vehicle or a workflow or an ecosystem of vehicles are capable of operating completely autonomously in all conditions, anywhere, anytime, without human intervention or supervision. There's no steering wheels, there's no pedals, the machine really is self-sufficient. So from a sales perspective, you're selling the future of agriculture itself. It's about integrated enterprise solutions that optimize every aspect of farming, from planting to harvest, involving multiple stakeholders across the entire supply chain. There's still going to be different islands of technology and information, such as agronomists working with machinery, working with weather predictions, all working together to build this ecosystem. So it's very different to what we're seeing today. the value proposition of this is the total optimization, maximum efficiency, minimal human input, and really unlocking levels of productivity that we're really dreaming of today. The layers of data don't only include the machine, but include absolutely everything around it as well. And this is where we're starting to really embrace the powers of AI to start looking at these other layers of information and integrating those into our everyday workflows. From the after sales perspective, the team are no longer going to be technicians. They're going to be elite technical and data science engineers. They're going to have technical expertise in AI, in deep learning, in advanced robotics, a comprehensive view of data analytics. The roles are not going to be reactive repair, but to proactive system optimization. Cybersecurity and data privacy are all going to be key parts to the roles of a dealer in the future. And it may seem as though this is a long, long way away, but we're starting to see the need for some of these already. So, fundamentally, the core is still the same. Even with all of the new skill sets and fundamentals listed in the last few slides, no farmer is going to buy in a machine or invest in a technology if they can't get the support that they need. And that is a critical point, that it would go back to fundamentals, that newer technologies still require support. It's a different type of support, but that need is still there. So I've talked about the different levels of automation and where we are within that cycle and the skill sets that are needed to embrace those levels. But now I'm going to go through some examples of the types of platform which are emerging that are commercially available today throughout the world or in parts of the world. It is worth noting that this is just a snapshot, and there are many more out there at different levels of maturity. So the first platform type would be a universal robotic platform, something which is designed to be autonomous and capable of performing a wide range of tasks, but also being able to utilize the hardware and implements which are already on the farm, which are reducing the cost of initial adoption to autonomy. You don't have to change the entire infrastructure on your farm. And these can be seen as a tractor replacement, which can slide or integrate or displace a standard tractor today and utilize the resources on the farm. One very successful example of this is AgSeed Agbot. It's based out of the Netherlands from a group of individuals who used to work for a major manufacturer, and they felt that the industry needed to change and that there was a huge opportunity for developing a ground-up machine which could displace a traditional tractor and integrate into a current farm working practice. There's a number of variances, but the one that I'm showing here is 155 horsepower unit mounted on Zoidberg tracks. Now, from a hardware perspective, there's a Cat 3 8-ton linkage at the back. There's a Cat 2 3.2-ton linkage on the front, 4 hydraulic spools, Isobus, Power Beyond, rear PTO, pretty much everything that you would expect from a standard tractor in the same horsepower bracket. So you have something which can easily displace the traditional tractor. But on top of this is their autonomy package, which from a hardware side is a combination of sensors, LiDARs, radars, ultrasonics, cameras, and physical impact sensors. And these sensors are new to the agriculture domain. So they will need to be supported in the field by the after-sales team. Essentially, the same with a tractor. Parts break, parts get damaged. We are in a tough environment and these need to be serviced. So from the sales side, new skills are needed in order to create a mission plan and to implement this mission, to embed, implement sequencing. So imagine not only selling a piece of hardware, such as a plow, but selling the understanding of how that plow will integrate into an autonomous platform like this. selling the feature of how that implement sequencing can be used with this machine as well. So these are being utilized in real-world commercial farms, and we're not talking about prototypes or research platforms, but real farming operations. Really pushing forward with their technology and gaining market presence. The next type of platform would be a retrofit autonomous system, because not everybody's ready to make the full leap into a dedicated autonomous platform. So we're going to see more and more retrofit systems which can utilize an existing tractor. So this is creating a machine which can operate at level 0, where everything is controlled by a human, through levels 1, 2, 3, and even level 4 automation, where the operator may not need to intervene or even monitor what that machine is doing. Think of these machines as the next evolution of a retrofit auto steer system, but where we're no longer just controlling the steering left and right, but controlling the braking, the speed, and the implement as well. We've just got a question come in. The AgSeed robot was listed with Isobus, but how does the Isobus factor into an autonomous robot? Okay, so Isobus is a communication protocol that goes across the entire platform of the machine. So utilizing Isobus TIM, for example, that's a tractor implement system. The implement itself can control aspects of the robot. So if the implement reports that it is going too fast and can't place a seed correctly, then a slowdown command can be sent to the robot. If it's an Isobus implement with a virtual terminal or VT or UT, then that view is passed to the remote operator, so they can also see exactly the input that a normal operator sat on the seat would see. So they can see if any warnings or anything coming from the implement. So that whole chain of implement connecting to tractor and tractor connecting to the remote operator is supported in the platform. So I hope that one answered your question there. So jumping back into the retrofit, an example company that are leveraging this is again based in the Netherlands. GPX Solutions, they've got it's what they call the iQuist. It's a system which is retrofittable onto platforms of multiple brands, with a number of different platforms supported. And they're really embracing the approach of not demanding a full step of all the way into autonomy, but de-risking by allowing your machine to be used for different operations with a larger operational window, and not relying solely on the fully autonomous ecosystem. When you start to get into this world as a dealer, although you will have to take some responsibility for the installation of the machine, making sure that you are retrofitting a system that is being done in a safe way, making sure that the safety systems will operate as intended. And just like when auto systems interfaced directly with hydraulics, these retrofit systems will have to interface with braking systems, steering systems, speed control systems. So again, from the sales perspective, this is a new workflow that you need to sell to your customer, but also you need to understand from an aftermarket or an installation perspective, your roles in making sure that this system is installed correctly. Okay. Carrying on with different robotic types, we have task-specific robots. Now, not all agricultural operations change throughout the season. Some tasks are very repetitive and have a long window of operation. So this might be in orchards where there's a lot of repeat applications of sprays or pesticides, or it might be a specific weeding operation with a large season. And these machines are designed to specifically service that one particular need and service it well. So from a dealer's perspective, you need to have an implicit knowledge about that problem which that autonomous system is trying to solve. It's no longer a generic approach, but selling a specific function or feature that is solving a particular problem or limitation that farmer is seeing. So an example of this one is a Jacto machine that's operational in South America. And based upon the uptime of these machines and the time of operator intervention, customers are seeing a 50% increase in productivity, where a supervisor is still responsible for filling the tank and doing the chemical mixers, but they are supervising multiple machines at the same time. So due to the size of the machine no longer needing to accommodate an operator's cab, then you've got greater tank capacity without actually interfering with the crop. And these machines can perform their task 24 hours a day. So a good example of how these machines are being utilized and are actually bringing benefit and value to customers today. And finally, on the different robotics types, we're going to start to see a new paradigm which could drastically change the way that we farm. Rather than having one large capital expense of a large, heavy machine, think of this as breaking that large expense into multiple smaller machines, which are all performing a subset of that task. Now that we're moving into a fleet concept, then that means there's combinations and interoperations of multiple platforms. There's a German-funded project under the way at the moment called Feldswarm or Fieldswarm, or multiple systems operating together, and they're really starting to embrace and develop this multi-machine concept of everything working together in an ecosystem. And from a commercial example, who are doing great work in this space, not specifically, although the name suggests swarm farm, but they are not small machines. These are very large machines. But an example of who are doing this is Swarm Farm. It's an adaptable platform that can work together to solve multiple problems. These guys are based out in Australia, very, very farmer-centric. They've created a platform and an ecosystem which is able to scale in a range of different use cases, from simple mowing through to crop protection. On this platform, they're often laying another piece of technology, such as spot spraying. And this really ensures that the end user is getting the most value out of their machine, as well as reducing their cost of inputs and labor. Another success story, they are covering millions of acres of land with these machines, and are doing great work in saving the amount of chemicals and inputs that are going onto the field. So, once again, even these platforms that I've talked about, these require dealers to really be the guys on the ground. They need to be the guys who are local. They are the guys who understand that farming operation, who understands that customer, and that is going to be key to these technologies being adopted. We can all push out a piece of technology, but if there isn't the person locally explaining exactly what that technology is and the financial and benefits to the customer, then it's not going to be successful. Now, going into more of the key technological components which need to be understood. So, as with hydraulics, electronics, and sensors, historically, autonomy will need a new knowledge around perception, missions, and diagnostics. Foundationally, an autonomous machine needs to have reliable positioning. An autonomous machine cannot be autonomous if it doesn't know where it is. And this has a fundamental tie into safety, that machine can only operate where it is deemed safe. Sensors are an implicit part to any design of an autonomous machine. There'll be a need to understand the limitations of those sensors in order to meet or level set the customer's expectations. Sensors are complex, and they will require a new skill set of understanding how to operate them. As more and more of the operation is a predefined workflow, i.e., you do your workflow up front, you plan it, then an understanding of exactly what the farmer does and why they do it is needed to actually digitize it. Therefore, we need to understand the exceptions of where it's going wrong, and really how can we optimize it further. And that's where the after sales guys are going to come in from the diagnostics and do retrospective analysis and keep these improvements happening time and time as we iterate through these technologies. And it would be unwise of me not to mention the elephant in the room of legislation and the legislative requirements and standards. So, as with any emerging technology, it's important to stay up to date on these evolving regulations, and they are evolving. There was a version of ISO 18497 put out in 2018 that was rewritten in 2022. So the policies and the design documents are constantly being evolved. And I do realize that there are some countries or states that are still relying on legislation from 50 plus years ago, which is limiting the uptake of autonomy. But that legislation will change. It's just a matter of time. From a data ownership and privacy and security perspective, there are rules and regulations such as GDPR, where we've got data protection if we're using cameras and capturing data, who owns that data, and all of this changes across the world and in different states. The liability of the machines is a big topic. So it is very clear, it's needed to have a very clear definition of everybody's role within the chain. What are the expectations on the owners? What are the expectations on the operators? What are the expectations on the manufacturers and service providers? And really define what is the intended function of this autonomous machine. And then once we've ring-fenced that, then we can be clear with the liability. And finally, training. Training is essential to make sure that these machines are operated safely and that the end users are getting their value from these machines. The training consists of how to map out the field all the way through to creating a workflow, all the way through to maintenance and support of these machines. It is a different workflow, it's a different ecosystem, it's a different paradigm of farming. So all of these need to be taught, and that is essential, once again, for the success of these platforms. So I have covered the levels of automation that we're seeing. I've covered the skill sets that are needed to meet those levels. I've covered types of machine that we're starting to see that are emerging. I've hinted at the legislation and the types of requirements that are coming and needed for adopting these autonomous machines. And now I'm going to hand back over to Chad for some final words.
Thanks, James. That was definitely very thorough. So over the last 35, 40 minutes, we've discussed the why and how autonomy will transform our farms, as well as what your skill sets the dealerships will need. But what can you do now to prepare for these transformations? Well, for starters, really have to start asking the big questions. How will autonomy impact my market? Who are my customers? What would it take to convince them to put autonomous machines in their fields? We saw through the poll a little bit ago, ROI is a big aspect. There's ROI of the machinery, there's ROI to safety, to yield impacts, farming improvements, and ultimately going back to the efficiencies that we talked about at the start. What types of machines would make sense for you, your dealership, to support? Is your marketing area more equipped for the ag seed style robot or the more smaller niche type robots? That's something that you'll have to consider for your own dealership and the markets surrounding you. The other part is be proactive. Identify where the gaps are in your current knowledge base and expertise that you have on staff, and figure out and create that timeline. How will you fill them? Where do you need to start first? And be ready to evolve. Expect to evolve with this. Create the support plan. If you get into technology or into autonomy, and you start with some of those early adopter growers that you have, build out a support plan, work with those customers. What do they expect beyond the lowest price and 24/7 response, or even a service person on site? But really getting down to what are the true requirements and be prepared for that. And then lastly, communicate. Communicate with your customers to watch for these changing trends. As more and more autonomy makes the news, more early adopters start to play with the technology, it will continue to evolve. And make sure that you're staying up to date and communicating with those growers that maybe show the first interest, as maybe perhaps something that delayed their decision could be evolved by now. And lastly, stay in check with industry peers and learn from those successes and the misses that have happened in the market. Ultimately, the long-term success of the dealership will at some point involve autonomy. Will autonomy define your dealership, or will your dealership define autonomy? In most cases, it's going to be both. To help prepare the dealership for this evolution, you must first become aware of the technology. Hopefully you are now after this session. And the expertise associated with the technology. Again, much of it covered today. That fundamental understanding will impact how autonomy can fit into your operation and how you can be a continued partner in your community with your customers through this next frontier in the ag evolution. Thank you for joining us today. This concludes our presentation, and we are open to any further questions. You can leave those questions in the chat, or feel free to reach out to us through email or our websites. Our email address is here on the slide, agriculture@hexagon.com. And I see we're starting to get a few questions. James, I will let you take the first one. How much better is an ag robot today than from the first ones 10 years ago? And if you were speculating, what are the advancements in the next 10 years?
Okay. So 10 years ago, the ag robots were really a matter of removing the operator from the cab. Let's say it was taking a standard tractor, pull the operator off the cab. And they were following a predefined breadcrumb trail of several latitude, longitudes, and it would just follow that line and it would do some implement sequencing. Now, 10 years ago, we just started to see those technologies paired with some form of perception, and that was likely a bumper bar, could have been a LiDAR, could have been a radar. But those sensors have been taken from the automotive world and just put on that machine. And when you start to take sensors designed for one use case and stick it on another use case, then really you're not lining yourself up for success. So the biggest differences are that the technologies have been more designed with agriculture in mind, which is increasing the uptime of these machines. Still not perfect, but it's far, far better. The second area of improvement is the ecosystem that goes around that machine. The machine driving up and down is only a tiny part of it. The workflow that goes into giving that machine its task is there. So that means that any farmer is able to create a mission plan and get it executed on their robot. The next area of improvement would be safety. The safety standards are pretty well defined now with ISO 25119 functional safety. In Europe, the Machinery Control Directive, the ISO 18497 highly automated agricultural machinery standard. All those standards exist and machines are starting to adhere to them, meaning that they are meeting the safety standards and expectations that are needed for these machines to be let out into the wild. So, quick answer, 10 years ago, it was a demo that would work in one particular scenario on one particular day. Now we've got the ecosystem and the safety where we can let these machines go out and do their autonomous operations. The next big advancement is how all of these autonomous machines start to work together and tie into our existing farming ecosystems.
Yeah, we have time for a couple more questions. If anyone has any Q&A box, bottom of your screen is the place to type those in. And we can go over the poll real quick if you guys would like. So the question was, what do you see as the key decision point for a farmer to adopt autonomous machines? A lot of the same answers we saw. People said return on investment, enough flexibility in the machine control to interact with existing farm infrastructure, productivity and safety. Is it a cost-effective way to address skilled operator shortages? Another person said reimagining the 12-hour workday, liability, labor shortage, again, price, recognizing labor savings and efficiency gains, confidence in the technology if the money makes sense, price point, and seeing the ROI of making that purchase decision. So pretty much what you would expect, or what are your reactions to some of those answers?
Yeah, for me, it's a lot of what I would expect. Labor is definitely the first thing that most people are thinking about, because that's really one of the first challenges that autonomy is set out to achieve is how do I put workers where they can be more productive rather than sitting in a seat doing a mundane task. I think beyond that, though, comes labor of being more attentive. How many growers have had an operator, whether it was themselves or a hired person who was in the seat, but just really did a poor job of actually working that field. So it's more than just the specific cost of labor, but it's also the labor of the difference between a good operator and a bad operator. It's the time, the window, as I mentioned earlier in the meeting, the window to apply continues to get smaller and smaller. So making sure that you don't have an operator calling in sick, that's certainly one of the things. But then also, everybody knows somebody who's had some type of a farm accident. And these systems, as they get more and more autonomous, they become more and more safe. And I think that's something that a lot of people are kind of overlooking and not thinking of from the ROI aspect. Other observations, I think they're definitely on point for what this community has been seeing. James?
Yeah. The only additional item on there, Chad, is simple return on investment. Am I spending the right amount of money on this machine, and will I get that return on that investment? So yes, we are at the beginning of this evolution, and at the moment the price points are higher. But that is coming down very rapidly with different business models, for example, and making these technologies more accessible. But it comes down to fundamentals. Farmers are businesses. Even if it's a family farm, they still need to feed their family. We still need to make a profit. And if that financial staple isn't there, then there's going to be less willingness. So ROI is definitely a key point. So obviously we've got another question there about how will it impact the Indian market. So the technologies evolve and move forward where the demand is there, where the need is there. So we're starting to see certainly a lot more in Western farming. We have the need because of our labor challenges that we have. In Eastern markets, it's a slightly different situation. We have a different type of primary tractor. So North America, mid-range horsepower tractor would be 180 horsepower. Indian markets, we're looking at 40 to 60 horsepower, much, much lower, different machine and different operation. But it's not to say that small machines don't have the opportunity for automation. An example of an Asian market which are really embracing autonomy is Japan. Japan have really moved forward with automation because their particular need again, is labor, but not so much labor availability, but the age of the labor. The average age of a farmer is far beyond what it is in Western Europe. So they're really embracing technology and automation in that sense. So these technologies are available, but it still comes down to the fundamental economics of here's my option and availability today. Is automation the right tool to solve the problem that I might be facing in the future?
James, I'll let you take the next one. The question's on the remote areas and about connectivity and machines losing connection. Have there been issues with this?
Yeah. So I'm going to use Swarm Farm as an example here because you can't get much more remote than Eastern Australia and where some of their machines are operating. So a lot of these machines are designed that they are not reliant on infrastructure once they receive their mission plan. Now, if they have connectivity, great, they can send the telematics information back. They can send their job status. But if they don't have connectivity, they don't just stop. They will carry on until there is a local exception on that machine that might prevent it from operating. So connectivity is not an essential part. It is should be designed as a nice to have in order to get to the uptime. But equally, we are seeing connectivity becoming more and more universally available with low Earth orbit satellites. There's now multiple connectivity solutions available at relatively low costs. So if your machine is reliant on a permanent internet connection, that might cause frustration and challenges. And if you get frustration and challenges, then you've not got a happy customer. And if you've not got a happy customer, you're putting your relationship at risk for future dealings. Now, at Hexagon, we provide. We're very well known for providing GNSS functions. On this connectivity aspect, we can provide high accuracy positioning anywhere on the globe without any infrastructure. So even if you lose your cellular connection, you're not going to lose your RTK signal. We have a technology called RTK from the sky. So that machine will keep operating throughout that cellular outage or that radio outage. And this leads on to the next topic. What products do we have? So we have the positioning side. So we have high accuracy GNSS receivers that have a whole range of different functions and form factors. So we have everything from RTK level with high grade inertials for accurate positioning of the machine, all the way to RTK networks and our PPP service, TerraStar, or our RTK from the sky services, which are really designed for machine uptime and availability of service. We have machine control products for navigating the machine. So that's controlling speed and heading and implements. And more specifically in the autonomy space, we have perception systems that can be fitted to autonomous machines to answer that what is around me question. So they primarily used for human and vehicle detection and unknown object detection to make sure that the machine's not going to traverse in a space that it shouldn't traverse. And finally, we have some functional safety products around geofencing, making sure that that machine is only operating where it should operate.
All right. Well, we're coming up on 3 o'clock Central Time, so we can go ahead and start wrapping things up. Great presentation, and thanks for that presentation, James and Chad. Any final words you want to share with our audience before we part ways here?
Thank you for attending. If there are more questions, hit that email address, agriculture@hexagon.com, and we will make sure that we respond. So thank you.
Yeah, and from my side, once again, thank you very much for the attendees. And it's not going to happen overnight, but we're here to help. And if you've got any questions, like Chad said, hit that email button.
All right. And we did have a couple of questions about will this be recorded? And the answer is yes, it has been recorded. And a recording of the session will be available within 24 hours in your email inbox, and also available on farmequipment.com, farm-equipment.com. So if you want to go back and watch something again or share it with someone at your company or your dealership, you'll be able to do that. Again, thanks to Chad and James for the presentation, and the entire team at Hexagon for today's webinar. And on behalf of us here at Farm Equipment, thanks so much for tuning in. We'll see you soon, and have a great day.